Namaskar, welcome to Exercise Explained. In this video, I will be doing question number 7 and question number 8 of exercise 3A Machines ICSE 10th Physics. The previous questions have been done in the previous videos, the link for which will be provided in the description below. If you like the video, do share it with your friends and consider subscribing to the channel. Starting with the 7th question. A 4-meter long rod, so the total length is 4 meter. So 4 meter can be written as 400 centimeters of negligible weight, that means we are not supposed to consider the weight of the scale, is to be balanced about a point 125 centimeter from one end. So it has to be balanced at a point 125 centimeter from one end. So as you can see here, I have balanced it at this point here. So the fulcrum has to be 125 centimeter from one end, and that is how we got this 125. So, and a load of 18 kgf is suspended at a point 60 centimeter from the support on the shorter arm. That means it is at a distance of 60 centimeter from the fulcrum, because the support is nothing but our fulcrum here. So that is how we got this 60 centimeter here. Now, since we have got the 60 centimeter, we need to find if a weight W, so there is a weight W that is placed at a distance 250 centimeter from the support. So from the support, now see, for the scale to be balanced, if 60 centimeter is there on the left side, then definitely it is heavier on the left side. So 250 centimeter we have to place W, and that has to be on the other side because left side does not even have 250 centimeter length. So it is 250 centimeter on the longer arm, so this has to be on the right side. So we need to find the value of this W. So for doing this, we will be using principle of moments. So for the A part here, I would write A part. So by moments, we can write 18 kgf, so I would be getting it in kgf only. So force into perpendicular distance, so the force is 18 on the left side into perpendicular distance from the fulcrum is given as 60 centimeter is equal to, we need to find the value of W, so W, that is the force on the right side, into the distance from the fulcrum is 250 centimeters. I can actually 18 into 6 is 108. So we get this as W is equal to, we get W is equal to 108 1080 divided by 250 goes to the other side, so divided by 250, 0 cancels, and after doing the calculations we get this as approximately 4.32 kgf. So W, we got it as 4.32 kgf, so that would be the value of W. So I hope this part is clear. I would write it here as 4.32 kgf. Now the next part of the question asks, if a weight of 5 kgf is kept to balance the rod, find its position. Now we need to find the position of a 5 kgf that is being kept. So this is a separate case. So here we would not be considering the W. So we would be considering only the left side weight. So the left side weight, again we will go by moments. So coming to the B part, again I would write by moments 18 into 60. So that is our left side. That is our what we call it as anti-clockwise moment. So 18 into 60 would give us 5 kgf into, we don't know the distance, but we know it is on the right side because the left side is definitely heavier than the right side. So if we get this 5 to the other side, we get x is equal to x will be a distance from here to the right side, from the fulcrum to the right side. This will be the distance x. So x would be equal to 18 into 60 divided by 5. 5 12s are 60. So 12 into 18 gives us 216. So we get this as 216 and centimeters. So 216 centimeters to the right side. Or if we wish to convert it to meters, we would have to multiply by divide by 100. So I would be dividing it by 100. So that would give me 216 divided by 100, that is 2.16 meter, again on the right side. So that is the answer that is given in the textbook. Now, third part of the question, that is C part of the question. So going to the C part, to which class of lever does it belong? Now since the fulcrum comes in the center, I have explained this in the previous video. If you have not checked that, do check that out, in which I have done question number 4, 5 and 6. So if fulcrum is in the center, it is a class 1 lever. So I hope this question is clear. Getting into the next question. A lever of length 9 cm has its load arm 5 cm. That means the load is kept at a distance 5 cm from the fulcrum. So here, this is the clue here, so that when it is given load arm is 5 cm, we should understand that from the fulcrum the load is at a distance of 5 cm, and that is how I got this 5 cm here. And the effort arm is 9 cm long. So the effort arm is 9 cm long. Now the clue is the total length of the lever itself is 9 cm, and if the effort arm is 9 cm long, that means the fulcrum is at one end of it, and that is how we got this here, that fulcrum is at the left side end. To which class of lever, to which class does it belong? Very simple. So here I would write A part. So it will belong to, since the load is at the center, it will belong to class 2 lever. So I would write it as class 2. After this, draw a diagram. So A part is done. I would just take that here. So A part is done. Draw a diagram of the lever showing the position of fulcrum, direction of both the load and effort. So that I have already drawn it. So coming to the third part, what is the mechanical advantage and velocity ratio? So for finding the mechanical advantage, I would be doing effort arm by load arm. So here I would write, this is the C part actually. So C part, mechanical advantage will be equal to effort arm divided by load arm. Effort arm I have written it as EA, and load arm I have written it as LA. Now our effort arm is 9 divided by load arm is 5. So 9 by 5 is nothing but 18 by 10. If I multiply numerator and denominator by 2, we get this as 18 by 10, which is equal to 1.8. So the mechanical advantage we get is 1.8, and velocity ratio if efficiency is 100%. Now we know the formula for efficiency. The formula for efficiency is given by the letter eta. that is written like this, something like n. So is equal to mechanical advantage by velocity ratio. So mechanical advantage by velocity ratio. So efficiency is the ratio of mechanical advantage and velocity ratio. So velocity ratio from this equation will be equal to, VR will be equal to mechanical advantage divided by efficiency. So mechanical advantage, we just got it as 1, divided by efficiency is 100%. That means we have to take it as 1. So 1.8 by 1 is 1.8 itself. So we have got velocity ratio as 1.8. We can also find velocity ratio by a separate method, that is VR. This will not be using the efficiency. VR will be equal to distance of effort, that is dE divided by dl. Now dE is 9 divided by 5. So 9 by 5 is nothing but 1.8. So as you can see, we are getting same answers both places. This is because efficiency is 100%. Otherwise this will not be working. So we have got the C part here. Now D part. What will be the mechanical advantage and velocity ratio if the efficiency becomes 50%? I have actually written this also by mistake, so this is not a part of this question. This is the second question. So yeah, what will be the mechanical advantage and velocity ratio if the efficiency becomes 50%? So the velocity ratio will remain same because it doesn't depend on that. So here I would write D part, VR will remain same. And coming to the mechanical advantage, so we know the formula, efficiency is equal to mechanical advantage divided by VR. Now efficiency is 50%, that means we can take it as 0.5 is equal to mechanical advantage divided by VR is 1.8 as we have got up. So we get mechanical advantage is equal to 0.5 into 1.8. So that gives me 518. So that gives me 0.9. So we get it as 0.9. So mechanical advantage is 0.9 when efficiency reduces to 50%. So we have got the D part also done. So hope you guys have liked the video. The next question onwards will be there in the next video, the link for which will be provided in the description below. Do check that out and do share the video with your friends. So see you guys in the next video. Till then, Dhanyavad.